to today's episode. So today on Cosmic Adventures, we're gonna be going to a planet, right? So today we're gonna be choosing a planet to explore, and the planet for today is gonna be Jupiter, right? So we're gonna travel to the Jovian System over here, and then let's see what Jupiter looks like. However, this is the real-time simulation of every single planet and their current trajectory around the sun, right? As well as their positions. So it's quite amazing. So this is like what it looks like currently out there, man. So as we zoom in to our solar system, you can see we're getting closer to Jupiter. Oh wait, it's still coming. Alright, so as we zoom in, you can notice that it took quite a while for us to zoom in from the overall view of our solar system to show you how massive our solar system is, right? So you can see how the Jovian system looks like. So it's called the Jovian system, and this is mainly because the planet was named after the Greek god of gods, which is Zeus. So, and that's mostly because the planet is the biggest planet in our solar system, and not just the biggest planet, but then the biggest planet by a long shot, right? It's the biggest planet by a long shot. And as we zoom into the planet, you can notice that it has amazing ring-like structures, right? You can see this. So this is actually clouds of ammonia and water, right, in the surface, and the surface of the planet is made up of hydrogen and helium gases, right? So these are the two main gases, and you can see it says here gas giant. So the reason why it's a gas giant is mainly because it is made up of gas, right? And this is quite interesting because this means that if you have an indestructible ship, right? Let's say you have a ship that is indestructible, and you can pass through this, and you fly into this point in the planet, and you fly out from this point, right? So it simply means you can fly in from this point of this planet, and you can fly out from this point, and you won't hit any hard rocky surface, right? You won't hit any rocky surface just like you would see on Earth, right? So it's just basically a ball of gas, right? It's just basically a ball of gas, and when you look closely, you can see that it has beautiful gaseous formations, right? You can see, just like I mentioned earlier, it has the beautiful swirling patterns that you can see over here is caused by ammonia and water in the atmosphere, right? So as we zoom out a bit, you can see the Jovian system. So the Jovian system is a system of moons that circulates around the planet Jupiter. However, on this simulation, NASA has covered 4 moons, right? Which is Io, the Europa, the Ganymede, the Io, the Europa, the Ganymede, and the Castillo, right? So these are the 4 major moons that we are going to be looking at, because these are the ones that are in the simulation at the moment. However, Jupiter has a lot more moons, right? It has 53 named moons, right, and about 24 unnamed moons, right? So it has so many moons, and like if it would be on this simulation, you'd probably see plenty more, like many more moons around the planet. And these moons are like the size of our moon, and they are really interesting. And that is just to show you a glimpse of how massive Jupiter is. It's just like a mini solar system on its own. And the planet actually has enough hydrogen and helium to burn like the sun, right? Not really to burn like the sun, but to radiate like the sun, because the sun is not burning, right? So when you understand how much pressure that has been compressed into creating an enormous gaseous cloud like this, compressed together to create a planet, right, as massive as Jupiter. When you understand how massive it is, then you will understand how possible it is for Jupiter to be an amazing system that we have to actually explore and look to find amazing information about our solar system, right? So you can see here it has at the poles, right? The poles are a slightly different color, which is quite amazing, because you notice a lot about the polar aspects of planets, right? Because planets are basically toroids, right? So a toroid is just like a feedback loop, right? So when you have the north, the magnetic north and the magnetic south, right, then you basically have an amazing structure, right? So when you're looking at, like when we're going to be exploring the planets, you notice that the north and the south often have a more unique structure to them, right, when you're observing them. However, there's an amazing structure on Jupiter which we are going to look at, which is this structure right here, right? So this is actually a hurricane, right? This is like a storm that has been raging for thousands and thousands and thousands of years, and this storm is as big as Earth. So if you're to bring Earth, right, you just put Earth inside. This is where Earth will fit. So Earth will just fit inside this place, just like this. It's crazy, right? So we're going to do a comparison between Jupiter and other planets so that you get to see what the size actually looks like, right? So, but it's actually an interesting planet. However, you would be wondering what this white orbit that you're seeing here is, and if you can guess, it is the handwork of our people. So this is an orbital spacecraft, right? So this is a spacecraft that is orbiting the planet Jupiter, and guess who sent it there? Us, right? Just explore an amazing system which probably belongs to an amazing set of people. It's quite amazing. All right, so let's zoom out of Juno. So Juno is an orbital spacecraft which is orbiting around the Jovian System. And you can see its path, right? You can see how massive the orbit is around Jupiter. You can see how it burns as the orbit approached Jupiter at this point. You can see how it bent away again, right? Showing how massive the magnetic pull of Jupiter is, and as well as its gravitational pull as well, right? So that's one amazing way by which we can make use of the law of nature, because the law of nature is fixed, right? We can calculate all this just from Earth, right? Scientists can calculate how the orbits, where based on the movement of the moons around the planet, the magnetic field, and where the orbits around the planet will be, right? Where the orbit channels around the planet will be, and set a particular course from Earth to Jupiter and fit it exactly into that particular orbit, right? So that's to show you how precise the laws of the universe is. And when we start to approach those laws inside our lives, in our various things that we are doing, then we can start to see, amazing results. So let's head over to the comparison side. So let's head over to the comparison side and let's see how massive Jupiter is. I'm trying to sing a song over there. Alright, so let's compare size. So you can see the size of Jupiter compared to Earth. So this is Earth when you put it side to side with Jupiter. Amazing, right? Crazy. So you can see how big our little Earth is. And let's head over to that great red spot. So it's called the great red spot, and it's amazing. I can see that Earth can fit inside this place, right? So the next planet, let's see how it is compared to our moon. So see how our moon is compared to it, and see how big Mars is compared to Jupiter. And Saturn, well, Saturn is quite big, but Jupiter is bigger. So you can see how big Jupiter is compared to Saturn. However, Jupiter has rings around it as well, but it's quite interesting that NASA didn't add it here, right? Just like these rings that you have around Saturn, right? So Jupiter has faint rings. In fact, the four gas giants, not gas giants, right? We have two gas giants and two ice giants, but then the four giant planets in our solar system have rings, right? And it's quite amazing when you get to look into the structure of those rings, because they are composed of amazing, interesting materials, right? That we can learn a lot from. So that's it for the comparison. You can see the size compared to Uranus, right? You can see the size compared to Neptune, right? So that's it for today's episode on Jupiter, right? So let's do a quick summary. So you can see here, Jupiter is more than twice as massive than the other planets of our solar system combined, right? So when you bring the major planets in our solar system, right? Because there is a lot more planets beyond the Kuiper belt in our solar system, but then the known planets in our solar system so far, when we bring all of them combined, right, Jupiter is bigger than it twice. So to show you the massiveness, if there's a word like that, to show you the massiveness of Jupiter, show you how massive the planet is. So you can see the distance from Jupiter to the Sun is 5.2 AU, which is 5.2 astronomical units. So 1 astronomical unit is the distance from the Sun to Earth, right? So 5.2 AU means the distance from Earth to Sun 5 times, right? So that's how far Jupiter is from the Sun. So the Sun will be quite tiny on its horizon. So you can see it has 79 moons, right? Which is quite interesting. So the night sky on Jupiter will be amazing. We have 1 moon over here. Imagine 79 moons. So you can see its namesake is the king of the Roman gods. And the length of 1 year is 11.86 Earth years, right? So it takes 11.86 Earth years for 1 year on Jupiter, right? So it's gonna be quite interesting. I'll just be like 2 years plus on Jupiter. So let me know how old you would be if you are on Jupiter, and I think I'm going to stick with the length of a year on Jupiter. So from now on, I'm using the Jovian calendar. The Jovian calendar. I'm going to write that down. The Jovian calendar. All right. Thank you so much for tuning into this episode. I'm so grateful. And Jupiter is an amazing planet, and there is a lot that we can learn, right, from Jupiter. However, it's not possible for us to identify any structure on Jupiter based on intelligent structures. However, it's interesting to see and know how beautiful the planet is, and we're going to be going into the moons. So Jupiter has interesting moons like Io, right? So in the next episode, we're going to be visiting Io. So this is an interesting moon. So stay tuned for the next episode.